Hi there, it's Mrs. Walsh, and this is lesson 6.6 where we actually begin graphing sine and cosine curves. So this is a little bit of review. Remember that the period is the horizontal distance of one complete cycle. The period is found by taking 360 degrees and dividing by the value of b. If we were talking radians, that would be 2 pi divided by b. The amplitude is the distance the graph travels above and below the midline. We can also think about it as half the distance between the min and the max points. So actually adding the min and the max and dividing by 2, half that distance. The amplitude from the equation is the absolute value of A. It's always positive. H in our equation is the horizontal translation, also known as the phase shift. It has that special name. Also remember that it changes to its opposite. So if you see x plus h, that's a move to the left. If you see x minus h, that's a translation to the right. K is the vertical translation. And it is what it looks like from the equation. Plus k means it's moving up. Minus k means it's moving down. So if we scroll down here, there we go. We've got these key points that are going on with sine and cosine. So remember that sine goes through the origin on its way up. It reaches a max, comes back down through the midline, hits a low point, and then begins to repeat. This complete cycle is one full period. So in this one full period, we've got 4 key points: an x-intercept, a maximum point, another x-intercept, a minimum point, and then here's where it begins to repeat. For cosine, it's very similar, but remember that cosine starts out at a high point, comes down through the midline, which in this case is the x-axis, hits a low point, back through the midline, and here's when it begins to repeat at another high point. So again, 4 key points in this period: high point, intercept, low point, intercept. Here's where it begins to repeat. The period and amplitude will affect the shape of the graph. So you can read these directions on finding sine and cosine, graphing them, I should say. I want to get right into the equations that are found on your next page. All right. So in example 1, we're graphing y equals 3 times the sine of 4x. It's helpful to consider what the period, amplitude, and horizontal and vertical shifts are. So we get that information from the equation. This 3 right here is our value of A, so I know that my amplitude is the absolute value of 3, which is 3. This value here, the 4, is my B. So this is my B value, this was my A. So my period of this graph is 360 divided by that value of B. B is 4, so that means my period is 90 for this curve. That means in 90 degrees, this graph is going to complete one full cycle. Notice there is no H and K, so there is no horizontal or vertical shift. So take your period, and there are 4 key points in this period. So this is a sine curve. Sine starts out at the origin. So I know this is my point on the y-axis. It's going to repeat in 90 degrees. Let me make this a little bigger. So I can go to 90 degrees which is right here, and I know that point is going to be the same as this point, because in this period of time, this 90 degrees, my graph is going to make a full cycle. So whatever it's doing here, it's going to start repeating here. And that's going to be true for every 90 degrees. So I could even continue on. 90 plus 90 is 180, plus another 90 is 270. We're going to have x-intercepts at every one of these points. And I could go to the left also, 90 degrees. Every 90 degrees it's going to repeat, so it's going to cross the x-axis. So in between these 2 points, we're going to complete a full cycle. What does the sine curve do in between the 2 x-intercepts? Well, it has another x-intercept. So in between these 2 points, 0 and 90, so at 45 degrees, it's going to cross the x-axis again. What does it do between 0 and 45 degrees? Well, we know that sine goes through the origin on its way up, so it's going to hit a high point in between 0 and 45 degrees. Now our amplitude is 3, so that means it's going to hit a high point at 3. So in between 0 and 45 degrees, I'm going to make a point up here at 3. And then I can ask myself, what is it going to do between 45 and 90? Well, it's going to be coming down off this high point, crossing the x-axis, and now it's going to hit a low point in between these two, 45 and 90. My low point is -3, so I can plot that point. Now, if I just look at these points, sorry about that. If I look at these points between 0 and 90, this is going to complete one full cycle. So that's what my curve looks like, and this pattern keeps repeating over and over. So in this 90-degree interval between 90 and 180, it's going to complete a full cycle as well. So I can plot these points. Here I have an x-intercept. Between these 2 x-intercepts, I have a high point. Between these 2 x-intercepts, I have a low point. There's my next cycle. Again, between these 2 x-intercepts, 180 and 270, I'm going to have another x-intercept. Whoops, need a pen. Then between these 2 points, we hit a high point at 3. Between these 2 x-intercepts, we hit a low point at -3. So again, I just keep repeating this over and over. Same is true on the left-hand side of the graph, where my angles are negative. Between 0 and -90, I have an x-intercept here. In between these, I have a low point. In between these, I have a high point. And you can see how we can continue on the pattern. Let's move on to example 2. This is a cosine curve. My amplitude, I get from this value of A right here. My amplitude is the absolute value of 2, which is 2. Notice that there doesn't appear to be a number before the x. That means my B value is 1. So my period is 360 divided by 1, which is 360. So my period is the same as it is for my parent function. So I know that this curve is going to take 360 degrees to make one complete cycle. So let's think about what cosine does at the beginning at x equals 0. What does it do on the y-axis? Cosine, remember, starts out at a high point. My high point is 2 because that's my amplitude. So at x equals 0, I have a high point of 2. I use the fact that my period is 360, and I go over here to where x equals 360 degrees, and I know I'm going to also have a high point at 2, because whatever is happening here at x equals 0 is going to be happening here at x equals 360 because it's going to start to repeat there. The same is true where x equals negative 360. We're going to be at a high point there as well, so I can plot that. Okay, let's think about what cosine does in between these two high points. Exactly in between these two high points is 180 degrees, and the cosine is going to be at a low point. So I can go back to 180 and plot my low point at negative 2. Same thing at negative 180. We're going to be at a low point because we're right in between 0 and negative 360, which are high points. In between the high points and the low points, the curve has to cross the midline, which is the x-axis. So at 90, we're going to have an x-intercept. And in between this low point and this high point, which is 270 degrees, we're also going to have an x-intercept. So I can go to 90 and plot that, 270 and plot that. Same thing at negative 90 and negative 270. And I can draw in this curve, and that is my cosine curve. Let's try one more example. Example 3, another cosine curve. Here's my value of A, which is 4. That means my amplitude is the absolute value of 4, which is 4. My value of B is 1/2. That means the period of this graph will be 360 divided by 1/2, which is the same thing as 360 times the reciprocal of 1/2, or 360 times 2, which is 720 degrees. So that means this cosine curve is going to take a full 720 degrees to complete a full cycle. This is only between 0 and 360. It's only going to go complete half a cycle here. If I look to the left to negative 360, between negative 360 and positive 360 is 720 degrees. So over the course of this whole piece of my graph, it will make a cycle. Okay, so we're talking cosine here. Cosine. What does cosine do at x equals 0? It starts out at a high point. The high point here is at 4. So remember, this graph has a period of 720 degrees. That means it'll be at another high point way down here at 720 degrees, which we can't see on this graph. What's between 0 and 720 degrees? Well, our halfway point would be 360. What does cosine do in between its two high points? It hits a low point. So that low point would be here at 360 degrees, halfway between 0 and 720. So I can plot my low point of negative 4 at 360 degrees. What does cosine do between a high point and a low point? It's going to go through the midline, which is the x-axis. So at 180 degrees, we have an x-intercept. Now the same is true on the left-hand side of the graph. It hits a high point here at 0. My next high point here would be all the way down at negative 720. Halfway in between is 360. That's where my graph is going to hit its low point. So negative 4 occurs, whoops, I need a pen. Negative 4 occurs here at negative 360. And then in between the low point and the high point, at 180 degrees, we'll have an x-intercept. And here are really my key points where I can draw this curve in, and that's how much I see of it, because the period is 720 degrees, which is pretty long. But you can see from negative 360 at a low point to positive 360, it hits another low point. So it does complete one full cycle in 720 degrees.